very simple step to recognizing alteration. And I'm going to be sharing my screen to show you some of the active work we are doing based on this. Can you all see my screen now? Can you see my screen?
Yes, sir, we can.
Okay. So actually you can't start any exploration without looking for fractures, for fault, and for some geological structures. I'll put in these geological structures that actually give us this boundary we actually used here. Then I will show you the radiometric interpretation and how we'll come about the potassium alteration and some of the evidence actually gotten from soil element sampling done in the field. This, first of all, we did the magnetic interpretation of this area with radiometric structures. So this is the kind of thing we have here. Now, basically, we were able to delineate these plates based on shearing. We think that there's a lot of criss-cutting structures within this particular zone. If you look at this, you can find out that this very quite a large number of areas. So there's no way you could have actually tried to carry out all exploration here. So you would need to actually target and narrow down to a particular zone. So what happened is we found out these primary structures running northwest, criss-cutting all the regional fabrics of the northeast. If you are used to the basement complex of this country, you'll be able to understand that most of the gold mineralizations actually controlled by this regional northeast faults, and also that of Benue Trough, all also run around within these structures. So now our interest is actually trying to understand some alterations. Then what we did was to see if you use radiometrics in looking at the alteration zones. Most of the time there's a mistake we made before, and we try to correct it as the years advances and experience could afford you. Now, if for example we are looking at alteration zones, and this is my thorium concentration, for example, and this is the area I've actually interpreted to have some shearing and some structures that are capable of hosting mineralization. Now, if you look at this regionally, using this thorium concentration, nothing actually will give you an indicative of any alteration here. Rather, you can see some structures anywhere running in this direction. You can see a structure here. But in terms of alteration, using a single concentration, you will not get that. So you bear that in mind. Now, that is thorium for you. Then, for example, you bring in this, which is uranium concentration. You can see that a very high concentration of uranium within this zone. But definitely, most of the alteration zones, when you're talking about gold mineralization, we are looking for low uranium concentration, and that of high thorium and that of high potassium. But in terms of looking for alterations or enrichment of potassium, which is very, very important and which is highly, it's very common, because you start from the commonest one, you can actually derive from your packages or from your data before going to some complex one that could take you to some geochemistry or analysis. Now, if you look at this particular plate, still, we can't pick out anything from in terms of alteration here using a single concentration. This is uranium concentration. Now, if you look at this is the potassium concentration. Now something happens here. Now, looking at this potassium concentration, it is expected that, wow, there's a depletion of potassium here. So we asked ourselves, what is actually happening here? There is a depletion here. Can we actually say that there's an enrichment within this zone for potassium? But actually, we can't be sure of that. So that's why it is very, very important you combine ratios of your radiometric data. Now, when you combine your thorium and your potassium ratios, something you will see an elevated values within this particular location. Then let's see potassium. You see, we have potassium and thorium ratios here. You can see there's an elevated values here. Now, if you look at this, there is elevated value of thorium, potassium here. And if you use uranium, potassium, you can see also an elevated value. So definitely that will tell you that there is something happening here in terms of attraction. But you couldn't have actually gotten that from single uranium concentration or single potassium concentration. That is what we did before. You see, that is uranium concentration. There is none. Now, how do we actually come about this enrichment of potassium to say that there is an enrichment of potassium here? We further went on to carry out some sampling and some soil geochemistry around this particular location. Now there is something that cropped up and it merged with the interpretation actually done in the office. Okay, we contoured potassium. For example, this is potassium in parts per million. You see? Now, this grid was actually done in 100 by 100. And you can see there is an enrichment of potassium on a very local, detailed level, unlike what we had before. Now, this is actually the fieldwork trying to provide some evidence of what we did before. Then if you look at this, now something again is striking. You see that the enrichment along this zone is actually associated with these primary structures running in northwest direction. And this actually coincides with the shear zone actually found before. You can see, let's look at what we had before, the shear zone. You can see this is actually what we had before, the shear zone. So you can see that the shear zone definitely must have some coincidence with an alteration zone. So these coincidences are actually very, very important. Now, look at this. This is what we said before as a possible alteration zone, but it's very, very wide on a very regional scale. But you can see the fieldwork narrowed it down to the actual zones. So here, they will tell you that definitely this place is, it's a place to actually concentrate on in terms of potassium concentration. Then you can see, let's bring the highest anomaly of the potassiums. You see what we're having here? So you can see, and you can see the concentration. This is on 100-meter intervals, and you can see how it goes. Now, if you want to see the actual, let's look at the anomalous points. Possibly we can look at the histogram of potassium here, or that of, say, let's look at the histogram so we can look at it and see the concentration we are talking about here. Okay, we'll classify this. Natural breaks is okay for it. We'll classify into natural breaks, even if we have, okay, let's have a maximum of 10 classics here. And if you look at this, you can see that your mean here is 2000, thereabout. And you have your standard deviation to be 1700. Give and take, we are talking about 3700. So within this place, you can see that within from here, 4926, you can see there's a break. So the entire region from here, all this is actually an anomalous zone. And that's actually what is plotted here, and you can see the highest number, we'll have 9852. That is about almost 10,000 ppm. So you can see that is a clear-cut enrichment. And if you look at the classics from 0, 6, 2, and all that, so even if you cut off this from here to here, it's a very clear anomalous, zone. So that is actually how we come about potassium alterations or enrichment here. You can see you can easily try to target these alteration zones, especially when we are dealing with some epigenetic deposit like gold, and most of what we have in Nigeria are actually vein type. You can see how it actually highly controlled structures. And again, there is something striking here too. If you look at this, to tell you that this is a kind of a narrow or structurally controlled, it's uniform and fixing a particular direction. So that will give you an insight that this is a maximum, this is a maximum area of concentration. So definitely whatever you're going to do. Now, some of you will ask this question. I don't know if you ask this question, why is it not fine in this primary, exactly on these primary structures that actually were interpreted? If you are very conversant with the schist belt, on a local level, most of the mineralizations are found some 500 meters, kilometers away from the primary vein, because this is like the conduit of hydrothermal fluid. So most of the time, the side or the auxiliary structures becomes the conduit for that. So I think this is how you can easily put up this. So why do we actually look at the alteration zones as one of the most important zones when you are going into projects of exploration, especially for base metals, gold, copper, lead, zinc, and all that? It's very simple, because we understand that most of these elements are mobile, and definitely gold can actually be leached out from the deeper zone to near surface zone, like the Gosant zones or the saprolitic zones, or maybe the lateritic zones. That's why you can see some of the gold in the laterites. Why? It's because there's mobility. And definitely when there is water, when they come in contact with water, and some of the sulfides, which turn to sulfuric acids, leach some of these materials to the surface. And once you sample them at the surface, because of the weathering profile, definitely you will be able to get some anomaly. But something again controls this, which is the weathering, which is one of the most important things that controls this, and also your topography. Definitely here, you can see that at this particular place, there is a kind of a cutoff. Why is there a cutoff? There is a possibility that the elevation here is high, and here is lower, and that is the case. So definitely if this place is high, and here is high, what do you expect? Your sampling definitely will not go down beyond maybe 0.5 meters. And most of the time, you found out that you sample within, unless you want to sample within the deeper zones, definitely that will be the reason why you might get it. So, but when looking at this way, you'll be able to understand that this might be actually as a result of topographical undulations and all that. So you have a cutoff within here and a cutoff within here. But definitely you can see there is a signature running in this particular direction.